said that even meant what?
Wait, both sides are the same.
It was symmetric over the y-axis. Both sides are the same across the y-axis. Odd was the same thing as symmetric to the
X and Y.
right, we called it the origin. You have to flip over both the x and the y. So I want you to take a second on your own for each of these. Tell me if it would be even, odd, or neither. What's this one? Even. It's symmetric over the y-axis. If you fold that thing on the y-axis, it overlaps itself. What about B? Odd. If you flip it over both the x and the y, then it would overlap. Two flips and it overlaps, so that's odd. What about C?
Odd.
Odd. One flip, this would come here, that would go over there, and then flip again, it would work. So that one's odd. And D?
Odd.
Odd. Okay. I hope you're not serious. Doing
Pretty serious.
Okay. So remember, when we're looking at even and odd, symmetric to the y-axis is even. So if it's even, think about where the y-axis is. Pretend that line was straight. Is it the same on both sides of that? So if you fold on that green line, it works. Odd requires two flips. So if we think if I flip just over the y, it would look like this. So that is not what we started with. So it's definitely not even. If I flip it again, if I flip over the x, this goes up, that end goes down, so then it's back to where it started. So that's what makes it odd. So this one, if we think if we just flip over the y, this comes over here, this switches, this one goes over here, so it definitely is not even because it didn't match what it started with. Then if I fold it over the x, that piece comes up, this one goes down, this one flips, so it's back to where we started, so that's odd. Does that make more sense? So it's really just a matter of remembering even and odd, which kind of symmetry are they describing. Now when we're looking at equations, we have to think about it a little bit differently. So this time, I didn't ask if it was even or odd. I asked you to test it for symmetry. And remember, there were three types of symmetry: x-axis, y-axis, and origin. So if I give you an equation like this, what we can do, if we want to check symmetry to the x-axis, look back at that notes handout from yesterday. When I said something was symmetric to the x-axis, that meant that it was the same above and below the x-axis, right? And we wrote down like f of y equals f of negative y. Whether you put in a positive or a negative y, you get the same thing. So if we want to check symmetry to the x-axis, what we do is make the y negative. So we're just making the opposite variable negative. Now what happens if you take the absolute value of a negative? It becomes positive. Is this what I started with? Mm-hmm. Yes, so this graph is symmetric to the x-axis. All right, so to check the y-axis, look at what we wrote down yesterday. If it's symmetric to the y, what's true?
Yeah, so X is opposite.
Positive x and negative x give us the same thing, so we make our x negative. All right. Is there any way to get rid of that negative? No. So this is not the same as the original equation. So this graph is not symmetric to the y-axis. How do we check origin?
Replacing x and y.
So if I make my x negative and my y negative. Okay, the negative on my y would go away because the negative in an absolute value becomes positive, but the negative on the x does not. So did this turn into my original? No. It is possible to get all three of these to be yes. It is possible to get all three to be no. So you really have to check everything.
If one of them is no, could it, like, is it possible to be the origin is a yes?
Yes. You could be symmetric to the origin only and not the other two. you will never have 2 yeses and 1 no, if that makes sense. So you could have no yeses, 1 yes, or all 3 will be yes. But it's never possible. If you're symmetric to both the x and the y, it will automatically be symmetric to the origin. But easiest just to go ahead and check them, because all we're really doing is plugging in negatives. So rather than trying to remember all the rules of what can and cannot happen, we could just check them. I don't want to do B. Let's see. Let's go to, well, we can do it. Let's do it. All right. How do I check the x-axis?
Flip the one.
All right. So if I make my y negative, is there any way to turn that into what I started with? No. How do we check the y-axis? Make the x negative. Okay, what happens if you have the absolute value of a negative? Is that what we started with? For origin, you do both. So inside my absolute value, that goes away, but on my y, it does not, so that is not what we started with.
So if either the x-axis or the y-axis is no, the origin's automatically no?
Not necessarily. Not if, it could be that both of those are no and the origin could be a yes. Let's do D. We're not going, I put a bunch of examples on here. We're not going to do all of them. So let's do this one. Too easy, huh?
No, this one will automatically be all of them are.
So how do you check the x-axis?
Flip the one.
If you square a negative, what does that?
Positive.
Is that what we started with?
Well, we wouldn't be able to get that though, would we? Because it wouldn't be squared. Oh yes, it would. Never mind.
Negative y times negative y is just a positive y squared. So that's what we started with, so that one's a yes. To check the y-axis.
Flip the x.
Okay, so if I make my x a negative. Negative x times negative x is
X.
positive x squared. And again, that's what we started with. So that one is a yes. If I did the origin, so we have a negative x squared plus a negative y squared. So negative x times negative x is positive x squared. Negative y times negative y is positive y squared. So again, that's what we started with.
Wouldn't we know that would be all 3 yes because they're squared?
If you recognize that and recognize that a negative square becomes positive, then yes.
Would we have to show the word?
You might just write me a little note of why you recognize it. That would be fine. Okay, questions on these? Checking for symmetry like that.
What would that graph like look like?
It's a circle with a radius of 5. So if you graphed it, pretending my circle is circular and doesn't look like a football. A little iffy.
Looks like a lemon
But
drop.
you could see then from the graph it has every type of symmetry. All right, last example I want to do is what if I give them in function notation? We talked about, we use the terms even and odd when we know we're dealing with a function. And a lot of times when we know we're dealing with a function, we'll have f of x, not a y in it. So you could change your f of x to a y and do it the same way we did the last example. We also talked about yesterday when I said something was even, what did I have you write down underneath that?
X equals f of negative x.
Okay. When I put in a negative, I get the exact same thing out. What did I write down for odd?
F of negative x equals f of negative y.
Negative x.
Yeah. Because for odd, symmetric to the origin, so it makes both the x and the y negative. So what we could do is just plug in a negative for your x. If you get the original function back out, it's even. If you get the exact opposite of your original, it's odd. And anything else, it would be neither. So let's look at that. So if I wanted to do f of negative x, so if I plug in a negative, a negative squared is positive. So negative x times negative x is a positive x squared minus 5. It's the same as what we started with. So that's symmetric to the y-axis or even. Okay. Next one. If I put in a negative, what's negative x times negative x times negative x? Is that what I started with? No. Is that the exact opposite, like multiplying my original by negative 1? No. If I took this times negative 1, I would have to have a negative x cubed plus 1. So it's not the opposite either.
It's neither.
Mm-hmm. All right. Let's see. If I put in a negative, okay, 5 times negative x cubed. So this means 5 times negative x times negative x times negative x. What does that equal? Negative 5x cubed. Minus a negative, so plus x. That is the exact opposite. It's like taking my original and distributing a negative through it. So that is odd. So even, odd, neither, it's not that the calculations are hard. It's just a matter of remembering what you have to do to check each of those things. Questions there?
Homework.
Not quite. Okay. I want you to find a partner.
Alright.
And get a piece of paper. You don't have to turn it in, so it can be scrap paper or on the back of your notes. There is a handout posted on Classroom. This is our part of our class, so this is not your homework assignment, but it's kind of some extra practice. I want you guys to kind of work through this and make sure we understand the even, odd, neither, the symmetry piece. So it's a little extra practice for that.
I have no one and nothing.
Make a group of five.
Join in. Come here.
Everybody pull this up. I'm going to do a couple of these with you, kind of show you what I mean. And then you're going to do some on your own. We may or may not do them all. Okay, does everybody have at least one pulled up for your group?
No.
Not just yet.
Not just yet. Being slow today, huh? So the first one gives you a point.
do one paper between the partners?
Maybe, you should probably each do it. You will get points just for participating in this, so everybody needs to participate.
Did you post it?
The handout, I think it's posted.
Yeah.
Okay,
It's Chromebook tweaking, sorry. Yeah, I found it.
so I'm giving you this point, and I want to know what point would be A, symmetric to the x-axis. So if I flip this thing over the x-axis, what does my point become?
Negative
5, 3. 3, 5.
3.
If I flip it over the x, that makes the y negative, does the opposite of my y, so it would be 5, 3. When you flip it over the x, it changes the sign on your y. So B, if I take this original point and flip it over the y-axis, where does it go?
Negative 5, negative 3.
Mhm. The picture is not required, I'm just doing it to kind of illustrate what's happening. If I flip this point over the origin, where does it go?
Negative 5, 3.
Yeah, origin changes the sign on both the x and the y. All right, so that should help you with number 2. We are going to do 10 through 15 together. So why don't you guys do, all right, work on 2 through 9 for a few minutes. So number 2, for the x-axis, your point would be,
Negative 6, negative 1.
and for B
6, 1.
and C?
6, negative 1.
All right. Number 3, what kind of symmetry does that one have?
Just Y.
Y-axis. Number 4 is
Yes.
all of them, and number 5 is
None.
none. Number 6 is even. 7 is odd. 8 is odd. 9 is
Neither.
Okay, good. All right. So number 10. What I'm telling you here is f of 3 equals 6. Okay, that's just another way of saying you have the point 3, 6. It's just function notation.
Wait, which question?
10.
Oh, whoa. I thought we were checking all of them.
We did.
Number
Is it
10?
Number 10 says
No,
the graph
2 through
y
8.
equals f of x
Look
is
at the
symmetric with
bullet.
respect to the origin.
The bullet above it. Oh, oops.
Oh.
Okay, so for this, we have to find the rest of it. So number 10, if it's symmetric with respect to the origin, what changes when you're symmetric to the origin?
Both.
Both. So this would become f of
Negative 3, negative 6.
equals negative 6. B, if it's symmetric to the y, what changes? The x. So it becomes f of negative 3 equals 6, because this is my x and this is my y. C, or not C, sorry, this is like 10, 11, 12, but you get the idea.
Oh, snap.
Number 12, if it's symmetric to the line x equals 6, okay, I was really kind of tricky here. X equals 6 would be this vertical line. So this point is 3 away from the line. So if I fold it, it would go 3 the other direction.
So we add.
So it's f of 9 equals 6. Had to throw
That's
a good
one.
thought question in there.
Lovely.
All right, 13. For all x, f of negative x equals f of x. That's just another way of saying it is even, or it is symmetric to the y-axis. So all that changes is the x. 14. For all x, f of negative x equals negative f of x. What's changing?
The 1.
And?
The X.
Yeah, it's another way of saying odd or origin. Both the x and the y change. 15. F is odd. If it's odd, what changes?
Both.
Both. Just another way of asking the same question. All right. There is a Math Excel assignment posted. It looks like it's longer, but don't panic. It's like 19 questions or something. But
It's just
a lot of them like required no work. If you have your notes from yesterday, it might say the identity function increases on what interval? What's the domain of this function? What's the range of this function? We wrote it all down yesterday. So it